Hi everybody. So in this lesson, we're going to be going over the sine ratio. Now, when we were talking about the sine ratio, this is something that you guys have not seen before. So you're familiar with Pythagoras, and we have one way of labeling triangles for Pythagoras, and it's A, B are our legs, and C is our hypotenuse. Now, this would be angle C, this would be angle A across from side A, and angle B across from side B. Now, instead of just labeling this leg and leg, we are going to label these according to an angle. So let's take a look at angle A here. So if I take a look at angle A, the side opposite angle A is side A. So this is the opposite side. So this leg is opposite. So instead of just saying leg and leg, here we have the opposite leg. Here, next to side A, but not the hypotenuse, because that's already something, that's already the hypotenuse. This is beside A, and another word for beside is adjacent. Okay, so now we have labeled our legs opposite and adjacent to be able to tell them apart. So if I tell you, the leg is 2 centimeters long, you're like, oh my God, which leg, A or B? So now I can tell you, oh, the opposite or the adjacent. All right, and sine A is just the length of your side opposite angle A divided by the length of your hypotenuse. So ratio is one side to another side. This is the opposite side to the hypotenuse. You might be able to guess already that the other two ratios, so this is the sine ratio, we also have cosine and tangent ratios, will be our adjacent and our hypotenuse and our opposite and our adjacent. So just looking at the ratios of the different sides to one another. So we can shorten this to just being opposite over hypotenuse, or even more shortened. So sine of A equals O over H. Okay, so we are going to use a calculator to determine the following sine ratios. We're going to round that to 4 decimal places. So your calculator will look something like this, hopefully. Maybe not exactly like this. So if you have a TI that shows, for example, what you're writing down, so sine, and it writes it up here for you, you will literally just put it in as it looks. So sine 25. So some other ones you will have to do 25 then sine. So just check with your calculator to see what you need to do. For this one, we'll do sine 25, and we get 0.422618, so on and so forth. And we'll be rounding that to 4 decimal places. Now, if you're not getting this number, you might have, if you're just getting 25, for example, you might just need to do it the other way, backwards way, so 25 then sine. But if you are getting this, if it does show you what you're writing, then you're good. Now, if you're not getting 0.422618 and you have exactly this in there, you might not be in degrees mode. So if you check on your calculator, just make sure you are in DEG, degrees mode, not RAD, radians, or GRAD, gradians. Okay, so make sure you're in degrees. If you are not in degrees, you need to hit this mode button and change it to degrees. So just make sure you're not in rad or grad. Make sure you're in deg. Okay. Get out of here. Okay. So sine 25 will be 0.422, then 6. Okay, then same thing. So finding sine of 74 by sine, and then 74. So it looks like this. You can choose to end bracket, so this will be important to do later, but right now you don't have to end bracket it. You can enter, and we got 0.9613. So 0.961, and then this will have to get rounded up to a 3. Same process. So clear sine 37. So sine 37 equals 0.6018. And sine of 89 is 0.9998. So again, really close to 1 here. Okay. Now, you may be wondering, why do I need to use this? Why can't I just use Pythagoras for stuff? Well, you will notice that in Pythagoras, there are 3 variables. So a squared plus b squared equals c squared. And you will notice that all 3 of them are sides. Now we're going to have a problem once we start, okay, I need to find this side, and I'm given a side and an angle. Well, if I want to use Pythagoras, I need to know what side A is, but I do not know what side A is. So I cannot use the Pythagorean theorem. So what I will need to do is use one of my trig ratios, so either sine, cosine, or tangent. Now you are obviously going to use the sine ratio for this lesson because this is the sine ratio lesson. Okay, so there isn't going to be a lot of things you're going to have to choose, but we are going to have to choose later which ratio is the most appropriate for the question. So since we do not know 2 sides, I know an angle and a side. That means I have to use a trig ratio, in this case, sine. So same deal as with Pythagoras, we will write it out first. So sine of A equals my opposite over my hypotenuse, because I know I'm going to be using sine because this is our sine lesson. So here we have the angle that we're given. Now this is an angle as well. Here I have another angle, but this is the angle that I know the actual degrees to. So I know this angle measure, so I'm going to label my sides according to this angle. Now across from this angle is the opposite leg, so opposite. Here across from the right angle is always my hypotenuse, which means that this is my adjacent. Now once we start getting into figuring out which which ratio we're going to use, this will be more important to make sure that you are labeling all 3 of your sides. But for right now, we're given this angle. We want to find this opposite side, and we're given the hypotenuse. Okay, so we will start circling 3. Once again, this is not that important now, but it will get important later. So circling 3, so 2 things we know, and then 1 thing that we're trying to find. So trying to find this side, and we know this angle and this side, our hypotenuse. And substituting right in. Okay, so next to our sine, cosine, or tangent, in this case sine, we will always put our angle. So our angle is 30 degrees. So sine of 30 degrees equals my opposite, which I'm trying to find. So x divided by my hypotenuse, which is 10 centimeters. So 10. Now solving for x, really easy here. So it's x divided by 10. So I will multiply both sides by 10. And you can write the 10 after here. It just might be nicer for you to start writing it at the beginning so you don't have to put brackets around your 30. You can just do 10 times sine 30, and you don't have to worry about end brackets there. Okay, so this reduces, and I get 10 times sine 30 equals x. Once again, just try to get into the habit of writing the 10 in front. And grabbing our calculator out. So clear. So 10 times sine of 30, and then you can end bracket, but you don't have to if you write it like this, and you get 5, exactly. And our units are centimeters here for our sides. So we get x equals 5 centimeters. Now, if I take a look at my calculator, and I would have written it elsewise, so clear. So let's say I did sine 30 times 10. So let's try that. So sine 30 times 10. Blast incarnation. Okay, so what it's doing is if I do not put an end bracket here, it's doing sine 30 times 10, so sine of 300 instead of sine of 30, and then multiplying that by 10. So in order to stop that from happening, either write the 10 out in front like we did here, so 10 times sine 30, or sine 30 end bracket, and then times 10, and there we get our 5. Okay. So, second example, remember our steps are to first label our triangle, then we will circle 3. So 2 things we know, 1 thing we're trying to find. We will choose our ratio, substitute into that ratio, solve, and don't forget your units. Everybody always forgets units. Okay. So taking a look at our angle. So here we have angle B that we know. So we know 20 degrees, and here is 3.5 centimeters, which is opposite our 20-degree angle. So this is the opposite side here, the side opposite the right angle. So our 90-degree angle is always our hypotenuse, which leaves our adjacent side, this last one. Okay, so circling 3 things. 2 things I know, 1 thing that I don't. So I know this angle, I know this side, and I'm trying to find this side. So once again, I'm going to be using my sine ratio. So opposite and hypotenuse, are the 2 sides that I circled here. So I will be using sine. So sine of B is going to be opposite divided by my hypotenuse. Okay, so substituting in. So sine 20 degrees is going to be my opposite, which is 3.5 centimeters. So 3.5 divided by my hypotenuse x. All right, so this is very similar but slightly different to our last one. So x was on the top in the numerator on my previous example, and now it's in the denominator. So remember, when x is in your denominator, you will need to get this onto the top. How I do that is, well, it's on the bottom, we need it in the numerator. So let's multiply by x on this side to get it off of the denominator. So get out of there, but what I do to one side, I also have to do to the other. So I get x times sine 20 equals 3.5. Okay, now x is not alone now, it's on the sine 20 side. So I need to get rid of that sine 20. So that x is isolated. Sine 20 is off of there. Oops, divide by sine 20, reduces, and I get x equals 35 divided by sine 20. Sorry, 3.5, not 35. So 3.5 divided by sine 20. Now you'll notice that if I take a look at what I had originally, that x and that sine 20 just switch places. So 3.5 is still on top, x has switched places with sine 20, and that will happen every single time you have to solve for something in the denominator here. So if you just remember, oh, if I'm in the denominator, these guys switch, then you're good to go. You don't have to do this middle step there. Just know that that middle step does exist. Okay, so x equals 3.5 divided by sine 20. So into your calculators, and you get 10.2333, so on and so forth. Right? I want this to 1 decimal place. So stopping here, taking a peek over, I won't round that to up, it will stay the same. So x equals 10.2, and my units are centimeters. All right, some word problems. So for word problems, if I do not give you a picture, you do need to draw one for me. And since they are word problems, I would like them answered with a sentence. So what is the height of the house if the angle of elevation of a ladder is 70 degrees and the ladder is 15 feet? Okay, now here I'm using a term we might not be familiar with. So angle of elevation, and down here I'm using the term angle of depression. So what are these two things? So angle of elevation is from the horizontal looking up. Okay, so angle of elevation from the horizontal and then going up. So this is an angle of elevation. So putting in some other things here. So what is the height of a house? All right, if the angle of elevation of a ladder, okay, so here's my ladder, is 70 degrees. Okay, so that angle is 70 degrees. And it's reaching to the top of a house. So here's my house here. And I have that my ladder is 15 feet long. So I have a 15-foot ladder. I have an angle of elevation, so from the horizontal up, of 70 degrees. And I want to know how tall my house is. So here's my picture. Now taking a look, here's my angle. So that means this is the side opposite my angle. And here is my hypotenuse across from my right angle, which means that this was my adjacent. Now I'm looking for the opposite side. I'm given my hypotenuse and I'm given this angle of 70 degrees. So using sine. So sine of my angle, so let's say angle A, is going to be opposite over hypotenuse. So your angle always goes with the sine. So sine of 70 degrees equals my opposite, which I don't know, divided by my hypotenuse, which is 15 feet. So solving for x, solving for what I don't know, what I'm trying to find. So it's x divided by 15, so multiply by 15 both sides. Remember, try to write it at the beginning. And we get x equals 15 times sine of 70 degrees. So 15 times sine 70 into your calculators. And you should get 14.09538, so on and so forth, feet. So we find out that the house is, and then let's once again just round to the nearest decimal place. Okay, so 14.1 feet tall or high. Next example. We have a lifeguard sitting in a chair that's 2.5 meters high, and he spots a child in trouble in the water at an angle of depression of 23 degrees. Okay, so angle of depression, if you're depressed, you're down. So if you have an angle of depression, you're looking down, and not from vertical down, horizontal down. Okay, so your angle of depression is going to be from the horizontal down. And that is how you find your angle of depression. So the most common mistake here is to say that this angle from the vertical to your diagonal is your angle of depression, but it is not always horizontal. So angle of depression and elevation, you start at your horizontal first and then down. So it's like you're looking straight out and then you look down, not you're looking straight down and then you look up. Okay, so angle of depression, straight out, then down. Okay, so here is your lifeguard. Okay, C is floating in midair. There. C is a child in the water. At an angle of depression of 23 degrees. So this angle right here, 23 degrees. His chair is 2.5 meters high. Okay. And then how far away is the lifeguard from the child when he is sitting in the chair? So sitting in the chair to the child, what is this distance? How far away are they? Now, here we have our triangle that we can use. We can also make another one over here. So this will also be 2.5 meters. So here's an angle, here's a side, and we are looking for this. So doing that, we have our picture drawn. Now let's label our triangle. So here we have the angle that we know, it's 23 degrees. Here is our right angle for this, and across from our right angle is our hypotenuse. And then here we have 2.5 meters, which is across from our angle that we are given. So this is our opposite angle. This is the opposite leg, which means that this is the adjacent, which we don't need because when I circle 3, circle my opposite, I'm looking for my hypotenuse, and I have this angle of 23 right here. Okay, so opposite and hypotenuse, I am using sine. So sine of 23 degrees equals my opposite, which is 2.5 meters, divided by my hypotenuse, which is x. Right? And then if you just remember how this works, if I have x in the denominator, it's going to switch spots with that sine 23. So it'll be x equals 2.5 divided by sine 23, just cutting out that middle step. And then in your calculator, so 2.5 divided by sine 23 should get 6.39826, so on and so forth. And my units here are meters. Or if we just do, once again, to one decimal place, that 3 is going to round up to a 4. So 6.4 meters. And since this is a word problem, I should answer in the form of a sentence. So the lifeguard is, yikes, 6.4 meters away from the child. One other way that we can draw this picture, and it might make a little bit more sense to you, so we're going to do it. So here I have my lifeguard sitting up here. Here is my child in the water, help me. Okay, here's the distance that the lifeguard will need to go. Here is the triangle that it probably seems more natural to use. So this is 2.5 meters high, and my angle of depression is still horizontal down. Okay, so this is 23 degrees. Now, if you remember from last unit, with our angle relationships, here I have one line, here's another line, and it is parallel lines. Okay, so if I have this angle and this angle, if you remember what that's called, we have alternate interior angles. And when I have parallel lines, alternate interior angles are equal. So if this is 23, this is 23 degrees as well. So here I have 23 degrees. I'm looking for this, how far away they are from each other. And I have that this is 2.5 meters. Now if I label this, here's my angle, here is opposite. Here is my hypotenuse, circling 3, I get an angle. I'm trying to find my hypotenuse, and I know my opposite side. So we would get sine of 23 degrees equals opposite, which is 2.5 divided by my hypotenuse, which is x. And you see that we still get the exact same ratio. So we will get the same answer, so 6.4 meters. Okay, just instead of having our triangle over here, we have it on the bottom. So instead of top triangle, we have bottom triangle. It's basically up to you which one you use. You get the same answer, as you can see, regardless. Okay, you can start your assignment.